So I'm going to talk to you today about kind of a number of different ways that I've been trying to understand children's development of analogy and how we can harness it and sort of capture it and try to optimize in the service of supporting learning by analogy. So first I want to just really clarify what how I'm framing analogy, the way I'm thinking about it. I know that all of you are interested in analogy, so you have probably a shared understanding here, but by analogy, the sort of most formal definition would be something like A is to B is C is to D, and then you have the same relation, right? So that's sort of the classic analogy. But of course, I'm really interested in real world context where you have really many aspects of systems going on at the same time. And this is something we've talked about in some of the other talks as well. Speakers have raised really interesting perspectives and important ways of thinking about this. So you're probably already thinking about the nature of these sort of same relations as not just being same. We're also looking at distinctions. We're looking at places. Sometimes in learning contexts, it's really important to attend to where the structures are not lining up. We are drawing in some ways on the perceptual information. In some ways, we're needing to figure out what to be inhibiting. So it's always kind of this comparing, contrasting, sort of multiple leveled comparison. So I'm really going to use the term structured relational reasoning because I want to think a little bit more broadly than sort of just this very clear same relation. Sometimes I'll use analogy and I mean this more complex relation, but that's really what I'm talking about. I also speak to educational audiences, and so there I'm also going to be talking about this as higher order thinking. And here Nina Sims and I have made an argument that when we're talking about Bloom's taxonomy, what does the term higher order thinking really mean? It's very kind of challenging to nail down. Bloom himself called his taxonomy the most cited, least read writing. And I think he's probably right about that. People take what they want from this idea of higher order thinking, but really what I'm talking about here is structured relational reasoning. And we've made this argument that it's really a core educational goal in many disciplines to educate learners to attend to relational structure and sort of reason on the basis of it, disattend to, sometimes irrelevant perceptual information. So this is I'm going to be using these interchangeably, but feel free to ask me questions to challenge any of these ideas, but I just want to kind of let you into the framework. All right, so I'm going to be talking a lot about mathematics. My educational work is in math, and the way that I think about this is that because mathematics is really this ideal place to look at structured relational thinking, it's a system of relationships, right? And we see relations between problems, between concepts, between representations of concepts. And developmentally, it's really interesting to think through, sort of even the basic building blocks of mathematics. So this kind of an equation is really by nature a relation, right? And mapping between this type of relation and this slightly more complex structure is one of these things that for an expert looking at mathematics, these are identical, right? This is an equivalence relation, you're balancing sides of the equation, but for children developing this scale, this is actually a pretty complex learning event. And they're really having, we see reliable developmental patterns in when children can actually, map accurately these relations. So this is really a learning event. And again, it's just to highlight, this is this process of mapping similarity, structured similarity across these contexts, but also recognizing places where the structure is different, right? It matters that there's another addend over here. All right, so, but I want to back up and sort of first sort of say that people are not great at this, right? So we know that, doing these kinds of structured comparisons seem really pretty simple, but I said that, people have to build these skills, and even community college students, this was from a study with US community college students, you see, when asked to solve these mentally, 77% of these students calculated each problem separately, right? But when this is sort of inviting comparison that would facilitate and make this process much more efficient, students are still not noticing or not using these relational opportunities that are in front of them. And these are students with adequate knowledge of how to do mathematics, how to solve these kinds of problems. They, are adults, they presumably have executive function, that's functioning. So, so I'm really interested in this question of sort of not only ability to do relational reasoning, but also likelihood of doing so. And that's part of, we know from the classic Chick and Holyoake studies, sometimes a real barrier to relying on using your prior knowledge or using these capacities is noticing the relevance of it in the first place. So educationally, I think that's an important piece. And developmentally, we want to know, sort of how does this happen? How does this unfold? So, last week, Dr. Mitchell had this lovely, I took a screen grab of her screen, showing how amazing people can be, right, at finding relational mappings. And, we're kind of equipped to do this. How do we get there? How do we develop these skills? Why are we sometimes so impressive at it and sometimes just really non-relational? We just don't notice, or we just sort of attend to kind of this, the more perceptual or more sort of object level relations or object mappings. Okay, so how do we figure those out? So the first thing I want to do is talk about the foundations of relational thinking skills and everyday home experiences. So again, I'm really going to try to center today in something more like everyday everyday learning and everyday relational structure mapping or structured thinking. And I want to try to get at some of the factors that shape ability and tendency to do relational reasoning. And these are things that, I and others have talked about a lot in the past, but I'm going to talk about some insights that we've been building. One is through observational data, looking at how language practices, everyday language practices, and socialization are related to these factors, as well as cognitive resources. And then I'm going to talk about some experimental work, looking at whether relational thinking is malleable. So is this something that just develops with age? We know it's highly correlated with age in certain ways, but is this something that can be shifted around? And is it malleable? Also want to look at neuro-cognitive factors and specifically executive function as being part of this puzzle. So is this a hard constraint? Are these things that can be moved? And if they can be moved, then how do we harness that for explicit pedagogy? So if we want to actually, up the chances that someone's going to think relationally, are there certain ways we can do so? And then if I have time, I want to bring in a little bit about equity and think about, if we know that cognitive resources are integral to this process, as well as the developmental landscape, what are the implications for real world context where, for example, things like executive function may be taxed systematically? So if I don't have time to talk about it, we know that executive function relies on, or anxiety can tax executive function. So if you have, these sort of systematic barriers to engaging and learning, for example, in the time of COVID-19, when, certain people are going to have more attention needing to be paid to other aspects of their environment, maybe you're going to find systematic differences in reasoning, in learning, and these can be really important. So I want us to kind of think about that. It's an area that we don't think about too much in the cognitive sort of analogy reasoning kind of world, and I think it's an important area. Okay, so let's talk about the language origins of relational reasoning. And here I'm talking about another term, higher order thinking talk. So taking this notion of higher order thinking and really looking at spontaneous language and thinking about how kids are actually using their language. So for this was collaborative work with Susan Levine and Susan Golden Meadow, who developed a language database of children's everyday home environments. And I'm going to be focusing on first the typically developing sample of children, 64 children recruited in the United States, and they were videotaped from 14 months to 58 months in 12 visits. Each time was 90 minutes per visit, so that's 726 visits. Yields 386,000 child utterances, right? So this is a lot of talk. This is everyday talk. This is unstructured home time. So an experimenter came and just set up a video, and the kids were asked to, parents and kids were asked to do what they would typically do. So we wanted to look at higher order thinking in this language. Are they using it? What does it look like? How does it change over time? So to give you an example of what kinds of things I'm talking about, here is a video of a parent and a child, transcript on the right. The red is higher order thinking.
Well, what do you think?
Teeth.
Teeth are your favorite?
Because it's your favorite, because if I didn't have any teeth, then I couldn't eat.
True.
And that's why I like, if I didn't have teeth, then I couldn't eat candy.
Okay.
That's why I like it.
Okay, so this is not deep world-shifting relational thinking, right? But what we see is comparative talk, sort of taking parts of the body, one compared to others, and there's a if-then, right, relation here that is being set up. And she has, this child has this really nice, if I didn't have teeth, then I couldn't eat candy, right? So she's actually doing really sort of a sophisticated construction here of thinking. This is the sort of thing we're talking about, right? This is the everyday kind of reasoning. There are some that are really kind of amazing, and then there are others that are quite mundane. So, sometimes it's a bit less meaningful. Here's another example.
The why, because, why, because, the why, because, the why, because.
Okay, you get the idea, right? There's not a lot of content here. But this child is picking up the language, the tools, and she's got the order right. Why? Because. And so what we think is that, this sort of everyday language is a place where kids are sort of learning the patterns, they're learning the routines, and they're learning these kind of discursive exercises of using relational thinking in communicative talk. So what does this look like as we see it unfold? So in order to try to distinguish and understand the differences between, for example, those two iterations we just saw, we also coded all 300 and whatever thousand utterances for whether they were really surface level or structure. So more surface level were things like, this one's red, so is that one. So it's a comparison, but it's really at this very surface level. Why? Without structure or content behind it, versus more structural kinds of higher order thinking talk. So are apples healthier than eggs, or why do I have a temperature, right? So these are ones that are actually capturing a little more content. And basically what we see is that kids are doing this. They are using this talk. The real onset starts around here somewhere around 27 months. There's obviously variability. Surface comes out before structure. No, sweetie. So you see surface reliably coming up before structure, and you see that increasing over time. So kids are much more likely to be using these surface HOTTs than structure. And it may not seem like that much. So the structure, by 58 months, they're using, on average, 4 to 6 an hour. But if you extrapolate that over the life of a child, that's actually, a pretty substantial amount of talk, and surface is more. So these are happening. Now, are these meaningful in any kind of a way? We do see that early higher order thinking talk is predictive of their later reasoning skills. So individual differences there. We see predicting Raven's matrices, Woodcock-Johnson verbal analogies, DARK, which is a reading comprehension measure, and Gates-McGinnity, which is a verbal inferencing task. We actually see the ravens as more related to the surface HOTT, while the others are more related to the structure HOTT, potentially because you have more language sophistication in the more structural higher order thinking talk. And so these are controlling for lots of things. So basically what this suggests is that children are doing everyday, using everyday higher order thinking talk. This is a feature of children's development. It seems to really matter for building these skills. They may start pretty simple, you know, why, because, but these really seem to be the foundation for what they're building. And this opens the door, I think, to thinking about where socialization is playing a role and where maturation is playing a role. So they're not just immediately starting high, you know, you do see this developmental trajectory. It isn't, you know, seemingly just about building the content knowledge. It's also about sort of building this practice of doing relational thinking. So to get at a little bit of more of the relationship between environment and sort of maturation of brain development here, we took a second sample. We have the same data for a sample of children with pre or perinatal brain injuries, slightly smaller sample, slightly less diverse. But basically we were able to look then a little bit more systematically at things like income as an environmental factor and brain injury status to get at whether, you know, differences in sort of predicted, you know, cognitive resources from a sort of a brain maturation perspective would have an impact on this developmental trajectory. And basically we find that they both do. So here we see that actually, probably those of you guys are doing more neuro work are, you know, wanting to know a lot more about the location, size of lesions, timing, all of that. And basically we find not a lot of differences by those. And partly that, you know, is because of the precision of our sample. Our sample is pretty small. So, but basically we don't actually see a lot. What we see are these kind of overall patterns such that income made a big difference. And we know that there are a lot of general findings showing higher language inputs in higher income families. And we find that here. We don't see differences actually, and in the other one by parent education or parent IQ typically. These are more about, it seems to be something about the sort of alchemy of income. So we see the higher income families, both for typically developing and the those with pre and perinatal lesions, in, you know, outperforming their peers, but we do see a big difference between the typically developing and brain injured children. So basically this suggests that, you know, having the resources does seem to be important, these sort of cognitive reserve in just their everyday talk, right? These are, you know, developmental trajectories, but also environmental inputs like input seem to be quite important. So again, we can think about, you know, what does that mean as far as, you know, equity and sort of what are we learning about the nature of homes and, you know, likelihood of sort of long-term trajectory differences. All right, so basically what I guess I'm trying to show here is that children's spontaneous language reveals a landscape of children's everyday relational reasoning use, right? So in discourse, we see this is something that kids are doing, this is part of their everyday childhood environment, and what they're doing matters, and what happens very early seems to be predicting what's going to happen later. But again, we do see this developmental trajectory. It doesn't suggest that, you know, we come in sort of fully formed reasoners. We see surface HOTT coming before structure, as we might predict. This suggests that really there is malleability here, you know, this has something, income gives us a window into the fact that there really seems to be some differences between the context and the way that context is actually going to play out in children's language development with relation to higher order thinking talk, but we also do see that there seem to be neurobiological constraints as well. So what I want to kind of think about next is the role of malleability. And so is this something that is really malleable? can we kind of attend to how we might change likelihood of using relational reasoning. So I want to focus on some studies looking at whether relational mindsets can be primed, right? So a mindset that would shift what you notice in a new setting, in a new context. So we took a part of a design used in adults with Debu and Holyoke, and we assigned 4-year-olds to 2 conditions. And here, building on their work too, we wanted to look at children generating relations versus listening to an experimenter generating relations. So this is looking at kind of whether the higher order thinking talk that children do matters. It actually, whether that actually is changing the sort of way that they're viewing the world, or whether it can anyway in a sort of a focus setting. So we had them do this priming task, which was where they did this active or passive relational talk. And then they did a scene mapping task where we asked them to say what they were attending to. So this was something about a relational orientation. So what were they noticing? What was their mindset there? So the active or passive talk piece was they had a matrix, and you'll notice there were really 2 kind of viable ways you could fill this in here. But we said, how do caterpillars go with butterflies? Then what goes with flowers the same way, right? So we asked them to either generate that actively, or we told them, caterpillars grow into butterflies, what grows into flowers. So either way, they had to come up with this D term, but the question is, who is actually doing that work of generating the relation in the first, the first context, A is to B, right? And here you notice they're saying grows into in both of these, A is to B as well as the C is to D setting. So so the differences were really asking for the relation. And then, so we first had this sort of spontaneous generation. If they didn't come up with the answer, we asked for it even more specifically. So we really did a lot of work to make sure that they could do it. And what we found is that, children were almost always successful. So they actually knew this relation. The problem here, if kids are not doing this, is not that they aren't recognizing, that they don't know how a caterpillar actually goes with a flower, for example, right? I mean, a butterfly. Then after that, we did a mapping task. And so this comes from scene analogy task, which we developed with Bob, which I developed with Bob Morrison and Keith Holyoke, and have used a lot, and I think others have used too. And basically here, there's always a scene in the top picture and a scene in the bottom picture. There's a relation in the top picture that's the same as the relation in the bottom picture, but the appearance of them is different. They're different objects. And sometimes we have a distractor. So in these cases, we always had a distractor, which is that the focal objects in the top, that's part of the relational grouping, is also just in the bottom as an object distractor. So they had the choice of either mapping relational structure, so here this one being pulled, or the object match, which is like truck to truck, right? So we were interested in what kids would do, and whether doing this relation mapping task beforehand would map the difference. So in the past, we've also, I should just say, we typically always use this as a relational task where we tell them, we train them in doing relational thinking, and then we see whether they can do it. Often they're still distracted by the object match, but here we wanted to know, if we just leave it open to them, what are they attending to, and can we shift that around? And so, yeah, I want to tell you what's like that in the bottom picture. So you see, relational versus the object matching there. And what we find is that our object matches were lower for the ones who are in the active condition. So we find that, more kids more often pick an object match than a relational match, but they did so less often when they had done this active relation matching or active relation generating task right beforehand. So this suggests, really, I think importantly, kids are kind of have to work to attend to relations, right? They are more kind of object focused, but this is valuable. This can be moved around when done in really explicit ways. And hearing relational talk, it doesn't do it. You know, it seems to be this actual active work of generating the relations that seems to be important. But this does suggest that noticing and reasoning on the basis of relation is malleable to socialization. This isn't like a hard constraint, sort of developmental age related, isn't about knowledge. It's about maybe this work of kind of doing relational thinking and talk. So you can think about how in a home context where there's lots of relational talk generated by the child we're seeing here, you know, but of course part of that is very much socialized by parents, right? So we are, you know, so far have only talked about the child side of the home language environment, but really, you know, we know that these work in concert. So really it seems to be that there's this, you know, social component to doing relational thinking and to building these skills. Now, do parents do this? Is this something that, you know, that happens? I'm kind of raising this as we think maybe that's the case. Do parents do this? So we did a similar task where we had parents and children talk about what they thought should go in this D term. So rather than the experimenter doing it, this was the parent. We didn't tell them what they should talk about. We didn't tell them what the right answer should be, right? So you notice that actually these are both green. They could pick a pink answer here, and then, you know, these would actually, this would kind of fill a solution, or they could pick on the basis of relation match, right? So we asked them to ask what they think would work and why. And what we did is we coded what the children did, and we what they said first. We coded what they answered at the end, and then and we looked at how that changed over time. We also coded who gave the relation, right? Who actually said that relational word. So we coded, you know, say money is stored in piggy banks. Who said the object? Who said the relation? Who said that object B, right? So we could get at this generation piece, the active versus passive generation kind of a piece there. And basically what you see is that at the beginning, sorry, this, anyway, legend looks funny, but at the very beginning on trial 1 and 2, you see the child is more likely, children were more likely to pick an appearance match than a relational match, okay? So this is before talking. This is at the very beginning. That was kind of where kids were starting. They were picking this object match. This goes with what I've argued, and we have a paper talking about bias in kids attending to objects, something lots of studies have shown. But then by the end, we see that actually this changes. They're no longer selecting the object on the basis of appearance as much, and they're really sort of, you know, they're becoming more relational. So when you look at their last choice being relational, you actually see that across the board, after talking with their parents, the thing that the family, the dyad settles on is most often relational. So this suggests that there's something happening. Parents seem to be coming in with the idea that relational matching is a better match than an object match, which I think is a really interesting orientation. And again, suggests that this is a, you know, sort of a function that at least these, you know, US parents took as a goal for their socialization, right? This was something that they should be pushing kids to do. And in fact, what we find when you look at the data, you see that the more parents scaffold the children to generate the A and the B relation, the more likely the child is to generate the C and D relation, the more that the parents scaffold the child to actually do the work of generating relation. We see that's related to greater relational skill. So on this study, we actually did a relational version of the scene mapping task. So we had a measure of really their skill. So in these families where parents were more likely to have their child generate relations, these kids turn out to be better relational reasoners. We also saw that parents who produced the relations themselves, that was negatively related to children's analogy performance. So it suggests that parents who are kind of bringing their lens of socialization, or they're kind of doing the work of producing these relations for these children, you know, we don't have quite causal link, but we see are less likely to have sort of, their children are maybe showing a slower analogy performance trajectory. So this suggests that parents are playing a role here, right? This, you know, we're really seeing parents having an explicit kind of reliable attitude towards relations over preferentially prioritizing relational attention versus object attention. And they seem to be doing work that aligns with what we see in this developmental trajectory. Now, okay, we said that there was this malleable piece. How about the cognitive piece? And so we saw that, you know, sort of early brain injury, sort of constraints on development and capacity, or, you know, sort of more work for plasticity is related to slower onset and rates of use of harder thinking talk. And how about what can we be more specific about what's going on? So with adults, you see the executive function system being a contributor sort of reliably to analogy scale. In young children, we've done a fair number of studies showing that early executive function predicts later analogy development. And I'll just talk a little bit about work showing correlations between individual differences in executive function and early childhood reasoning, as well as in later childhood, when we're looking at more school-based kinds of learning, we see that executive function still seems to play an important role. So just one study with children between 5 and 11, we gave them, oh, sorry, wrong. No, sorry, wrong task. I don't want to go through this. Okay. Okay, here we are. So we looked at measures of the executive function. We used 3 tasks: inhibitory control, working memory, and dimensional card sort task. These are using the National Institute of Health toolbox. That's in the US. They've the National Institute of Health developed a online set of materials that was designed to be shared. And then we had children solve scene analogy problems. As I've mentioned before, they either had the perceptual match or the relation that was common across these two. So you could have a relation match between, the person who is actually here, the agent of the relation. So we asked them here, we gave them instruction and we asked them to do relational reasoning. And basically, we replicated things that we've seen before, where we find that distraction, so having this perceptual distraction there, so that picture of the girl that looked the same as the girl in the top one was likely to reduce children's performance systematically. That was true to 7 and 8-year-olds. We didn't see it with 9 to 11-year-olds. We also see that adding relational complexity, so adding 2 relations in there, was also likely to decrease performance, which again, we have argued before would likely be a function of working memory. So requiring the reasoner to hold multiple relations in mind, right, and grapple with it. That builds on things Graham Halford argued. And so what we find here is that, in fact, these 3 measures of executive functions did predict these performance patterns, but actually the strongest predictor was working memory. And in other work that I've done, some of you, Alex Dumas and Bob Morrison and I have described data in which we use inhibition paradigms or parameters to predict differences in relational learning and in relational performance. I'm not stepping away from the argument that inhibition is really crucial here, but I think in this particular task, our kids are a little bit older. They're 5 and 6 and 7 and 8, and here it seems like working memory seems to be the real driver of differences on this particular task. Also, our working memory measure is a list sort measure, and it requires, a lot of these working memory tasks require some inhibition, whereas the inhibition task is a flanker, which is a very, very basic sort of low level, more low level responding. So I think part of the issue when we're trying to think about and find relations between measures and performance is the nature of the tasks themselves, right? This is the real challenge with executive function work. Okay, so, but we do see here some, evidence that individual differences in these skills are predicting performance, which gives us more kind of leverage to think through what these constraints are on doing learning later by analogy. So does this matter for learning? So in classrooms, we have mathematics that requires lots of attention to key properties of relations that are being displayed. If we have manipulatives and graphs, these look different. We have to inhibit attention, not be, attending to this. We need to hold this relation in mind, particularly, when we're faced with other complexities in a classroom. You might see other things going on in classrooms. You see, here, these are two other studies that we've run looking at comparisons between problems, comparisons between solution strategies to the same problems. There's always a lot going on. These are high working memory load kinds of problems, or kinds of representations. So we think that that role of cognitive load might be particularly important as you move into increasingly complex educational landscapes. So you have this sort of driving development and then maybe continuing to be important, but just the nature of the task is going to change the nature of the specific executive functions that are constraining your relational reasoning. So I'll just tell you about the paradigm that I use for doing my classroom level studies. So now I'm shifting into the educational side of things. And what we typically do is we videotape a classroom, a real classroom lesson that is designed to require relational thinking. And here, many of our studies look at comparing either problems or solutions, teach it in the classroom, once with real students, videotape with multiple cameras simultaneously, and then we can edit those videos to create stimuli that are identical, but with whatever piece that we want to manipulate being different, right? Or we can hold instruction constant and, for example, correlate it with executive function measures. So we know that the instruction is always going to be identical. These are interactive, so we ask them to answer questions, but all the complexity of a real classroom is there with the minimal, constraint that it's on a video, right? So a lot of my work deals with ratio, in part because at least US kids are really bad at ratio. What's the different definition of a ratio? One student says the definition of a ratio is a musical system people like to listen to music on, right? So I don't know, I guess it's something in your car, a lot of different ideas, kind of like a race, skin color, I don't know. Okay, so we had lots of different kinds of things. US kids are bad at this. So it's an area of importance educationally. It's also one of these nice areas where kids are likely to not know your information before you teach it, which is a challenge in classroom kinds of settings. And I'll just tell you about one study here where we looked at individual difference measures of executive function and looked at whether they were related and could predict learning. So we can kind of nail down that this is something we need to think about when we're talking about increasing learning from analogy in classroom settings. And here, yes, we did hearts and flowers. We did a stop signal task. I can talk more about these if people are interested later. And really what we find is that both inhibitory control and working memory were important in predicting students' learning from this comparison lesson. So this suggests that with the identical lesson, kids who came into this lesson with different available executive functions were learning differently. So from this work, we've done, lots of other studies to figure out ways to reduce the cognitive load and reduce the executive function demands on learning. So I think, I would argue that that's an important way to go if we're trying to kind of harness the potential for analogy in learning settings. So this is a powerful tool. We know this already, but we know that students may not actually be benefiting from opportunities to do relational reasoning. So they may not benefit for two reasons. One, because they don't notice it, right? That's about the mindset. So whether they're kind of noticing that there is a relevance of attending to relations as opposed to sort of the object level features of these comparisons. And secondly, because they're lacking the resources to kind of hold the complexity of these representations in mind, map them, and actually, build this schema level knowledge that would be likely to transfer to post-test performance problems. So I'll just very quickly, make the point that if that's the case, there are lots of things that load situational cognitive load. And so when we talk about cognitive load, when we're talking about individual differences, in the reasoning literature anyway, most of the time, we're sort of talking about these as stable individual differences, but we do know that, the loads increase in different ways. So one of the ways can be by identity pressure. So, knowing that someone may be, holding a stereotype about you can load your worry and your sort of need to protect your identity. And we know that this can, have systematic effects. So just for those of you not familiar with stereotype threat, this is a theory that has, it's part of the replication crisis. There is a lot of challenge and debate about stereotype threat findings, but I think part of that is really about the details of the mechanisms that are not always part of the paradigms and the way that things are being studied. So I'll just give you the background framework, which is that, the original studies had men and women take a test, and if they were told there's no gender difference on this test, that was one condition. Another condition, they were told there's a gender difference on this test. Men typically outperform women. Basically, what you find is that that's what happens. And so there are a lot of replications of stereotype threats and the effects on test performance in different ways. We wanted to know whether if the mechanism, one of the theorized mechanisms is that this loads cognitive resources, their executive functions, with verbal worries. So if you're saying to yourself, oh gosh, I don't want to look like a woman on this, like I got to do well, I don't want to look like a woman, don't mess up, then you're essentially taking resources that could instead be put towards high working memory load tasks. And it's what the typical finding is that stereotype threat is actually higher for highly identified individuals in a context and higher on high working memory load test problems. So we looked at it in analogy context, which is a high working memory taxing learning context, and basically did a very similar paradigm to what I described. The only difference was that we started with a prompt saying, researchers at the University of Chicago conducting an important study of how students like you learn math. Please answer question 1 of your packet, where they were asked to either identify their gender or their birthday, right? So that it was either a threat or not a threat. And then they were given a lesson like the one I described. They were given a D2 measure of attentional control. This is a nice group administered measure, but it's not a high-powered computer delivered EF measure. But basically with that, we replicated the mean effective EF. So with lower EF resources, you see lower learning and performance. And so that's what you see here. But when you add the stereotype threat, we replicated this fact that with the high EF, it was the high EF students that actually learned much less than you would predict when they were given this, pretty minimal threat before learning. So this is one study. We're now looking at, and then also there was an impact beyond content. And we see that those under stereotype threat were more likely to show less enjoyment, less intention to learn more. And when we gave them optional math problems just to solve in their free time after the study, they solved less of those problems. So suggests that there were kind of these broader, not just learning effects, but also potentially motivational effects, which could affect long-term trajectories of staying in STEM fields, these kinds of more sociological kinds of changes that might be really impactful and important. So this suggests that a threat of a stereotype, or maybe other kinds of anxieties like related to COVID-19, may impair not only their knowledge representations that they're building, but also their longer term interest and engagement. And both of those can have impacts in fields like mathematics, which build incrementally. So if you learn a little less today, your next math lesson is going to build on what you learned today. So you're actually going to potentially see these kinds of systematic problems. So this is, I think, one window into ways that we need to think about how the constraints on analogical reasoning and relational reasoning more broadly might be impacting learning as a whole. And, if we're thinking even more broadly about developmental trajectory, what this might look like as far as building relational mindsets, building attention to relations, and, think about how we can explain, some of these findings. All right, So to conclude, we've really talked about analogy, starting in the home, right? Starts with these everyday language kinds of experiences. And then you have parents socializing children potentially through language inputs, as well as potentially through sort of explicit or at least maybe implicit theories about what are sort of best ways of thinking or more adult-like ways of thinking. We seem to show that relational thinking is malleable, can be primed, but there are some constraints with executive functions being one in particular. And it seems like we can really harness this for explicit pedagogy if we're aware of these two kinds of constraints, and we can set up learning events that are most likely to be successful and to build knowledge. And we can do so with an eye to equity, right? Really thinking hard about how we make sure we're ensuring that, students are all able to notice and benefit from instruction that's being provided, and sort of to build, kind of to the maximum capacity. So I'll here, there are many more people to thank on this acknowledgement slide and funders and things, but I will end there and open it up to questions. Thank you.